This video is about section 9.1, proportions. We will construct hypothesis test comparing the proportions of two populations. So we will look at two populations, and for each population we will get a sample. We'll call them sample 1 and sample 2. Based on the data we get from sample 1 and sample 2, we can calculate a test statistic, which is a z-score. And we know based on the z-score we can calculate a p-value. And then we will compare the p-value with the given alpha, the significance level. And the rest is the same as the hypothesis test we done before. So this is the general procedure. We will use this homework problem as an example. It says, test the given claim, identify the non-hypothesis, alternative hypothesis, test statistic, p-value, and then state the conclusion about the non-hypothesis as well as the final conclusion that addresses the original claim. Okay, here's where the problem starts. Among 2,195 passenger cars in a particular region, 238 had only rear license plates. Among 326 commercial trucks, 47 had only rear license plates. A reasonable hypothesis is that commercial trucks owners violate laws requiring front license plates at a higher rate than owners of passenger cars. Okay, use a 0.05 significance level to test the hypothesis. And A, test the claim using a hypothesis test. B, testing the claim, constructing appropriate confidence level, confidence interval. Okay, by reading the problem, we can see we have two populations. The first population is the plate violation in passenger cars, and the second population is the plate violation in commercial trucks. And we get a sample from each population. The sample from population 1, let's call it sample 1. What does sample 1 tell us? Among 2,095 passenger cars, 238 violate the license plate law. Okay, so here we can tell the sample size for sample 1 is 2,195, and call it x1 is 238. Okay, so with that we can calculate our sample proportion for sample 1, p1 hat, that is equal to x1 over n1, which is 238 out of 2,195. From population 2, we also get a sample. We will call it sample 2. And in sample 2, the sample size is 326. And x2 here is 47. So similarly, we can calculate the sample proportion for the second sample, which is 47 out of 326. For P1 hat and P2 hat, we can calculate the corresponding Q1 hat and Q2 hat. Well, Q1 hat is 1 minus P1 hat, whatever that number is, and Q2 hat is 1 minus P2 hat. Another thing you need to know if you calculate this by hand is something called pooled sample proportion. We use P bar to represent that. P bar equals x1 plus x2 over n1 plus n2. In this case, it will be 238 plus 47 over 2,195 plus 326, whatever that number is. And Q bar is 1 minus P bar. These values are what you need if you want to calculate by hand. Of course, if you use technology like StatCrunch, all you need is these four values, n1, x1, n2, x2. Let's go back to the problem. Since this is a hypothesis test, we need to find the claim. What is the claim here? It's over here. A reasonable hypothesis is that commercial truck owners violate laws requiring front license plates at a higher rate than owners of passenger cars. You want to compare population proportions. So if the population proportion for population 1, P1, and the population proportion for population 2, P2, then our claim will be, okay, commercial truck owner violates laws more, right? This corresponds to P2, right? And passenger cars, that corresponds to P1. So it says P2 is at a higher rate of P1. So P2 is greater than P1. Or if you want to put P1 at first, will be P1 is less than P2. That will be the claim. Okay, so based on the claim, we can write our null hypothesis and alternative hypothesis. So the null hypothesis is always with the equal sign. So P1 is equal to P2. And the alternative hypothesis is P1 is less than P2. Before we conduct the hypothesis test, let's check the requirements we need for this test. First requirement. The sample proportions are from 2 simple random samples. It does say random in the problem, so yes. Second, the 2 samples are independent. Well, it is independent. It's not like one sample value is depending on the other one. So they're dependent. Okay, so number 3, for each of the 2 samples, there are at least 5 succeeds and at least 5 failures. Or in other words, n p hat must be greater than 5 and n q hat must be greater than 5 for each of the 2 samples. Okay, let's check those. All right, if you look at n1 p1 hat, n1 is 2,000 something, and p1 hat is, well, this over 2,195. Okay, so it's pretty obvious this value is greater than or equal to 5. Right, and similar for P1 Q1 hat. Okay, it's definitely greater than 5. If you do the calculation, you know, the number of failure in this case will be 12195 minus 238. Definitely greater than 5. Okay. Similarly, you can check for your N2 P2 hat. This is 47, number of success. It's equivalent to your X2 actually. And the number of failure which corresponds to N2 Q2 hat. This number will be the number of success, will be 300 something minus 47, which is definitely greater than 5. Okay, so based on this simple, brief calculation, we can say the third requirement is also satisfied. Now we can start the test. So here I want to introduce two ways. One is to calculate by hand, and the other way is to use StatCrunch. I will focus on the StatCrunch way more because I believe if you calculate it by hand, it's a little bit overwhelming on the calculation. But I will still give a brief introduction to it, so we know, the procedure. If you calculate the test statistic by hand, you will have to use this formula over here. As we can see, you will need your P1 hat and P2 hat over here, which we can find it, based on the value we know. And P1 minus P2, even though we don't know what our population proportions are, we assume that they're the same. So P1 minus P2, this is 0. And the rest, we can find the rest of the values from the problem. Anyway, after you calculate the z-score, whatever that is, you can use the z-score to find the p-value. And then compare your p-value to your alpha. So here I won't elaborate on that. I want to focus on the StatCrunch method. If you go to StatCrunch, where you want to go is under Stat, Proportion Stat. I know we're using z-score as our test statistic, but you will go under Proportion Stats. So here we're dealing with not one sample, but two sample. All right, it's with summary, not with data. All right, number of success is asking for your x1, which is 238. Number of observations is the sample size, 2,195. Okay, for sample 2, the number of success is 47, and the number of observations is 326. All right, so first let's conduct the test. All right, so the null hypothesis is P1 minus P2 is equal to 0. This is equivalent to say P1 is equal to P2. All right, the alternative hypothesis is, well, here it says P1 minus P2 is, well, since P1 is, okay, what is that, our claim, our null hypothesis? Alternative hypothesis, P1 is less than P2, so this is equivalent to say that P1 minus P2 is less than 0. So here at StatCrunch, we'll say P1 minus P2 is less than 0. Okay, so that's all we need to do, compute. All right, here you can find the z-stats and the p-value, depending on what they need. If they want the z-score, it's negative 1.902 if you round it to the nearest 1,000. Right? That's the z-score. The p-value, the StatCrunch gives us is 0.0286. All right, so since we have the p-value, we can compare it with our alpha, which is 0.05 over here. Right, that's the significance level. So this value is smaller than your alpha, 0.05, which means our test statistic is significant. Right, so we will reject the null hypothesis. And there is sufficient evidence to support your H1. In our case, you can say it's P1 is less than P2, or the plate violation for commercial cars is less than the plate violation of the P1 is the passenger cars, right? The passenger cars is less than that of the commercial trucks. And this is the end of the hypothesis test. There is a B part for this problem. It says, test the claim by constructing an appropriate confidence interval. If you do it using StatCrunch, it's fairly easy. You don't even have to put the values all over again. Just go to options here, edit. So instead of hypothesis test, you go to confidence interval. Okay, so what is the confidence level? Well, that's based on your alpha. Here's a little bit tricky. How do we find the confidence level for this problem when we know your alpha is 0.05? Well, first of all, what is alpha? Alpha is your area in the tail, right? So since this is a one tilt test or a left tilt test, your alpha will be over here. This is 0.05 for alpha. Okay, but when you construct a confidence interval, it's always a two-tailed thing, because it is always a point estimate, whatever that is, right? You plus a number, you got the left or the right critical number, the right critical value, and you subtract the same number here, you got the left critical value. So for a confidence interval, it's always a two-tailed thing. This 0.05 only restrict your left tail, didn't restrict your right tail. So you have to add your right tail there. So you have to assume there's another 0.05 over here, because we're doing a confidence interval. The left and the right needs to be symmetric. So in this case, your confidence level should be 0.9 instead of 0.95, because you have to use 1 to subtract 0.05 and another 0.05 from both sides. So that is why over here at the confidence level, instead of 0.05, you put 0.9, because confidence interval is kind of like a two-tailed test. Okay, compute. And here you can find your left limit, your lower limit, and the upper limit. Right? That's your confidence interval. So your confidence interval is from negative 0.06, well, 0.070, I will call it, if you round to the nearest thousandth, to negative 0.002. Okay. Okay, so this is your confidence interval. How do we use a confidence interval to make a conclusion? Remember, this is the confidence interval of P1 minus P2. That means P1 minus P2 will be in this interval, right? So the interval shows it will be negative because all the values in this interval are negative. So from here we can say there is sufficient evidence to show that P1 is less than P2 based on the confidence interval. That's how we find the confidence interval and make a conclusion out of that.